Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will try to see what are the different types of real numbers that are available in the C, along with how signed and unsigned number work, how the range of integers is determined, and the storage nuances of the negative numbers. So these are all the things let's try to see. So about the float. So real numbers are nothing but float double and the long double. The first one is the float. It occupies the 4 bytes of memory. So range is approximately minus 3.4 E382 to the 3.4 E38, used for storing smaller floating point numbers. I have an example code for this one, so I will try to show you. So here this is our float value 3.14f. F indicates the float literal, and the float value, if you try to check it, the output will be something like 3.14000. So this is how you will be able to store the value. And the next one is the double value. So double occupies the 8 bytes. The range is approximately 1.7 E3082 to 1.7. So here minus 3.4, right? So this one will be 1.7 E3082 to 1.7 E308. So more precision than the float. So if I try to show you the example for this one, here if I try to print, so here 3.141 something higher precision. So you will be able to see the value for this. Okay. And another one is the long double. So long double occupies 10 bytes of memory, 10 bytes or more depending on the compiler, used for extremely large or precise floating point number. Let's see for this one also. I will have a simple example. So I am trying to take bigger one. If I try to run this one, so here you will be able to see the long double value. So depending on the compiler, it will try to store it. So now the next one is the signed and unsigned numbers. Signed numbers can represent both negative and positive values, whereas unsigned numbers can only represent positive values, effectively doubling the range for non-negative values. So you already know for signed character we are maintaining as minus 128 to 127, and for unsigned 0 to 255. So we will be mentioning with the percentage C. So that is one thing. And for the short int, so what we will be trying to do for the short int? So for the short int we will be using minus 32 to 32,000 like this it will be, and for unsigned it will be 65,000. So the number of bytes occupied is the 2, and you will be indicating for the signed is percentage HD and for the unsigned is percentage HU. So for the integer, so integer will be different. So for this short int we have learned it, right? For the int it will be something around minus 2000, a very big number, okay? And unsigned will be 0 to something like this, and the number of bytes is 4, percentage D and the percentage U. For the long int you will be using percentage LD and the percentage LU. For the long int you will be using percentage LLD and percentage LLU. So these are the different ways how you will be format specifier will be using it. So this is all about what we will be trying to do. So I will try to show you a simple example for this one also. So character thing, signed and unsigned thing. So here we are having a signed character and unsigned character. Percentage D and the percentage U is the things which we will be trying to see. So here you will be able to see minus 128 and the 255. So storage of the negative numbers. Negative numbers are stored using 2's complement. So I will try to show you the things, negative numbers, how it will be stored. So here negative numbers are stored in using 2's complement. Steps for storing minus 128 in a signed character is find the binary for 128. So here 1 and 0 0 0 it will be. So for 1's complement it will be 0 and 1 1 1 1 it will be. So add 1 to the 2's complement, 1 and 0 0. So here store 1 0 0 in the 8 bits. So this is how you will be storing the value. For example, I will try to show you this one in the code. So here the MSB you will be able to store it. So here minus 128 you will be able to see the minus binary representation stored as 10000 like this. So now the next one which I want to tell is out of range behavior. So I already told you that out of range behavior is a cyclic behavior. If you attempt to store a value outside the range of a type, means it wraps around due to the overflow. For example, plus 128 in a signed character results in minus 128. So here plus 128 results in a minus 128, and storing minus 128 result in the 127. For example, here it will be resulting in the minus 128, okay? And if you try to take it as a minus 129, it will store it as a 127. So you'll be able to see it as an minus 127 here. So this is how you'll be able to see it. So specifying the constant. So integer constants we can use add L, capital L or L to treat it as a long. So you can use it something like here. I will try to show you. So here long integer, you can mention it as in 23L long integer. Floating point means you can add F to treat it as a float, or add LL to treat it as a long double. So I will try to show you this code example also for this one. So here large int you can use it with capital L, float you can use it F, long double means L you can use it. So here the implementation will be like this. So this is how you will be mentioning. So the next, that is all about this concept, about this floating concept. So use float for smaller decimal numbers, double for more precision, and long double for very large and or precise numbers. Signed types allow negative values, whereas unsigned types increase the positive range. Be cautious of overflow behavior when working with the fixed size data types. Use suffixes like F, L or L to explicitly specify the type of constants. So this is all about the different type of float related thing. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.